Hello everyone, in this video I'll be explaining 5th A program of data structure laboratory, that is evaluation of postfix expression with single digit operands and operators plus minus star slash percentage and power. So percentage is nothing but a reminder. Now before moving on to the program, I will explain the postfix evaluation with an example. So let me consider a simple example. Two, 3 plus 5 star. 2, 3 plus 5 star. This is a postfix expression. How are we going to perform the postfix evaluation? And postfix evaluation requires a stack. And whenever we get an operand, that means first of all you need to read a character of the postfix expression one by one. First I will read the first character of the postfix expression, that is 2, and I will push it onto the stack. Whenever I get operand, I will push it onto the stack as I told before. And 2 is done. Next I will move on to the next character that is 3. Since it is an operand, I will push it onto the stack. Next coming to plus. When I get plus, what I will do is I will pop topmost 2 symbols from the stack. So first one what I am popping will be, I am going to term it as operand 2. So operand 2 will be 3. Next I will pop the next topmost symbol, that is 2. So, and after that, right now I have a plus operator in my hand, so I will apply plus between these two. So OP1 plus OP2, I am going to get 2 plus 3 is nothing but 5. So this result will be pushed onto the stack. Now earlier this was popped. So we can remove this. So we have nothing in the stack. Next word. Next I will get a next operand. I will read a next character from the postfix expression, that is 5. I will push it onto the stack. After that I get a 1 operator. When I get 1 operator, what I will do is I will pop the topmost 2 symbols, that are first one what I am popping is operand 2. Second one what I am popping is this, and this will be this. And then I have star in my hand, that means I can perform multiplication operation between these two, and this the result. Once I get this result, I will push the this answer, that is result, into the stack. So the stack content will be now 25. Stack content will be now 25. The stack content. And now star is done. Now we have reached the end of the expression. End of the expression in the sense, since it is a string, it will be a null. Then when you reach that, you can pop the result, that is 25 you can give as a result. So final result would be 25. So this is how you have to perform the operation. Let's understand the program. Now first of all I am going to include here the necessary header files: stdio.h, math.h, stdlib.h and ctype.h. Stdio is for printf and scanf function. Math.h is for if you are using a power function, you can include math.h. and then stdlib.h is because I have included here exit of 0 function, and then ctype.h is for isDigit function. I have used here isDigit function. And the program is about postfix evaluation and which makes use of a stack. That is why push and pop functions are necessary. The definitions of push and pop is same as earlier. That was defined in the stack program as well as in fix to postfix program. Then as usual you have to declare a stack of maximum size and the top need to be initialized with -1. Next we have our main, and main is the entry point for any C program. So this need to be there in the C program. And we have declared the necessary variables like operand 1 and operand 2, and here we are going to store the operands, and then the I is necessary to loop through all the elements of the to go through all the elements of the postfix expression. Then the postfix input postfix is stored in the held by postfix expression, and the symbol will get the character by character. After that, result will be stored in the result variable. And I will ask the user to enter a valid postfix expression. So that is actually facilitated by a scanf function, so which will be a string. Next I will read all the elements of the postfix one by one after the other. First I will go to the zeroth character of the postfix. Zeroth character of the postfix is 2. Next first character, next 2 character, and then the third character. Third character would be null as this is a string. So when I is 0 first time, postfix of 0 will be postfix of 0 will be 2. That is initialized to that is assigned to symbol. And once you and after that you are going to check that whether the symbol you have got is digit or not, that is by isDigit, and that you are going to convert it to a decimal and put it onto the stack. And after that if suppose it is not a digit, if it is an operator, then you're passing the character to a switch case. Now here, if the operator is a plus, then pop the topmost 2 symbols and apply the addition operation and push the result back to the stack. Similarly, apply the minus operation. If the character is star, corresponding operation will be applied on the topmost 2 symbols that have been popped. And similarly, we can apply the division operation and then percentage operation, and after that the power operation. Power we can here I have implemented a power function. You can also make use of the mathematical function, and then store the result in the stack. After that, end of case, and then end of file. This is not end of file, this is end of for here. And after that, once end of for is done, that means the end of the postfix expression is reached, then you can pop the result from the stack and give the result to the user. So here, as I've told, I have used a push function and pop function, and corresponding definitions I have shown here. Then I have used even a power function. What is power? 2 to the power, suppose operand 1 is 2, operand 3 is 2, 2 to the power 3, that is equal to 8 need to be written by this function. Let us verify this. Since 2 power 3 is nothing but you are multiplying 2 3 times. Multiplying 2 3 times. So that is it's a multiplication operation. That's why the result need to be initialized with 1. First of all, let's check operand 2 is not equal to 0. Initially 3 is not equal to 0. Then result initially is 1. Result will be equal to result into operand 1. So 1 into 2 will be 2. Then subtract operand 2. So operand 2 minus minus will be 2 now. So this is what operand 2. After that again go back to the while loop. 2 is not equal to 0. 2 is not equal to 0. The result gets updated because result earlier was 2. Now again if you multiply with 2 you get 4. Then operand 2 will be decremented. Operand 2 will become now 1. Again result gets updated as while condition is true. So result will be now 4 into 2, which is equal to 0. Now if you decrement operand 2, you will get operand 2 is 0. And once operand 2 is 0, return the result. What's the result? Result is 8. This is how this power function is going to work. Now we'll see the output. Now let me compile the POSTFIX evaluation program. So that's why I'm using GCC compiler evalpost.c -o eval. Output will be stored in the eval. The compilation is successful. Then again I will get the prompt. Now I will run the program, run the file, that is executable file, that is eval. So now I will get the output window. Here I am going to enter the postfix expression. Postfix expression should contain numbers. You can't give alphabets here. So 1, 2, 3. All these are single operands. Plus star and then 2, then star. And the output is 10. Let me type you all and explain the infix. This is the postfix expression of the infix expression. 1 plus 1 star 2 plus 3 1 star 2 plus 3 star 2. If you evaluate this, what you are going to get? 1 star 5 star 2. So this is nothing but 10. Now let us evaluate. This is the infix expression. For this postfix expression is what I have given here: 1, 2, 3 plus star 2 star. Let me tell you how to evaluate. So first of all, you push operand on the stack 1. Next you push 2. Next you get character 3 that you push, and after that you get a plus symbol. When you get a plus symbol, pop topmost symbol, that is 3 and 2. 3 and 2. So this should need to be initialized as operand 1. This need to be initialized as operand 2. So apply operator 1 plus that is plus operator on operand 1 and operand 2. So 2 plus 3 will give you 5. So that is you need to store in place of this. So you have to pop these symbols. You have to pop these two symbols, that is 2 and 3. So the result will, the stack will now contain 1 and result of 2 and 3. Okay. Next we get star. Once processing of plus is done, now we have star. Now what to do? When we get an operator, as usual, pop two symbols. Operand 2 will be 5 now, and operand 1 will be 1. So 1 star 5 will be 5. 1 star 5 will be 5. Again, this will be popped. Both the symbols will be popped. This will be popped, and this also will be popped, and you push the result back to this. Now we have 5. And after this, again you will go to the next operator, next character of the postfix expression, that is 2. So 5 and 2. Now we have star in hand. So when you get a star, what you have to do? You have to pop the topmost two symbols, that is 2 and 5. Operand 2 will be 2 and operand 1 will be 5. Apply star on them and you will get 10. So this is the result of this fixed expression. now we'll see the next stack application, that is Tower of Hanoi problem. Tower of Hanoi problem needs two things. One is the pole, another one is the disk. Pole in the sense you need to have a three poles. That's like a stand where you can place. It's a placeholder for a disk. Okay. Now here our aim is to move the disk from the source pole, this is a source pole, to the destination pole by making a move one at a time. And remember, whenever you are placing the disk, always the larger has to go down and the smaller has to sit on the top of the bigger one, next bigger one. Okay, so now suppose if there is only one disk, if you have only one disk, let's number this as 1, and what you can do, you can directly move this disk to the destination peak. So this is your source. Let me write here source, and this is destination. Directly you can move. Suppose if you have a two disks in the source, so smaller one can sit on the top. So this is 1, this is 2. Let's number this. 2 is bigger than the 1. Now how we are going to move it to the destination? Always you have to make one move at a time. So what I can do is I will move the disk 1 to the auxiliary peg, auxiliary pole or a peg. So I'll move this to here. So 1 will go here. Next what I will do, I will move this to here, the bigger one. 2 I'll make move, and after that what I will do, I will move the one smaller peg to here. 1 will go here. So this is how I can make the moves so that I can put it in the destination. And here you can see that while placing, the order is not changed. Now coming to the program, as usual we include stdio.h, then I have declared the prototype of the function, that is tower function. This will do the moving of a disk from a source pole to the destination pole. Next I have written the main. Main is entry point for a C program. After that I have declared the variable for number of disks, that is num, and I have read the number of disks. I am going to read the number of disks using scanf function, and then I am going to verify whether the number of disks users have entered is 0 or not. If it is 0, I am going to give the information to a user saying that there are no disks, so you can't move any disk from the source peg to the destination peg. Else what you can do, suppose the number of disks are greater than 0, in that case I am going to show the sequence of moves involved in the Tower of Hanoi. So that's why I am going to call the towers function. Towers function will do the job of moving of disks from one source to the destination. So towers will need 4 parameters, that are number of disks, source peg is named as A, destination peg named as C, and the auxiliary peg is named as P. And finally I am going to return 0. If this job is done, I am going to return 0. That means it's end of the job. Let's understand the towers function. Towers function here, as I told previously, will contain 4 parameters: number of disks, from peg, to peg, and auxiliary peg. So this is a recursive program. I have built Towers of Hanoi using a recursive function. So that's why for a recursive function or a program, you need to have an initial condition or a stopping condition. What's the stopping condition? That is only when a number is 1, you are going to just make a simple move the disk 1 from the peg wherever it is to the destination peg, from peg to peg. Next what? Next is, suppose if the number of disks are more, let's consider the number of disks are 3. So to move the disk from peg to the to peg, what you have to do? First we have to move n-1, that are 2 disks. In this case n-1 disks are nothing but 2 disks. I am going to move from peg to the which peg it is? Auxiliary peg. I am making num-1 from peg to the auxiliary peg using which peg? 2 peg. From peg to the auxiliary peg using 2 peg. After that, there is only one one disk is remaining. That is the largest one. That largest one I will directly move from peg to the 2 peg. So directly move disk from peg to the 2 peg. After that, there is only two remaining here. N minus disk, whatever I have placed here, n minus 1 disk, whatever I have placed here, I will try to move it to this 2 peg. Okay, that is from the auxiliary peg. I'll try to move it to the 2 peg using from peg. That is what explained in the Tower of Hanoi problem. Okay. Next, let's see the output. If you compile the output, it will ask you to, if you compile and run the program, it will ask you to enter the number of disks that are 3. So let's see the sequence of moves involved in the Tower of Hanoi are. So that's why I'll consider the example, consider the 3 poles, and I will consider 3 disks. That is 3, and I will show the moves that are performed in the output. Okay, first of all, 3, bigger one is at the end, next 2, next 1. First I will move disk 1 to where? Disk 1, because my aim is to move n minus 1 disk to this place, so that I can move this directly to here. To move the n minus 1 disk to here, what I have to do, first I have to move disk 1 to this place. So move disk 1 from peg A to peg C. So that what I can do, move the disk 2 to this place. Move the disk 2 from peg A to peg B. So this is A, this is A, this is C, this is B. So first what I did, move the disk from peg 1 to peg C, peg A to peg C. Move the disk 2 from peg A to peg B. Then what I will do, only one is remaining here, that I will directly move, not one, there is one here, isn't it? So that I will place it here, because as the peg, the disk what I moved here is 2. Okay, what I moved here is 2, and here I have 1, here I have 1. So what's the best way to solve this problem? Erase, not, let me show you properly. Now what I have to do, now 2 is bigger, 1 is smaller, so this I can move it here. So move disk 1 from peg C to peg B. So move disk 1 from peg C to peg B. So once this place gets vacated, so what I can do, move disk 3 from peg A to peg C, from peg A to peg C. So that's why here I'll have 3. Now bigger one I have here, that is 3. Okay, so this is 3. Once I have here 3, next it is 2. I have moved here 2 and 1 has gone here. So now what is the job? Now I have to move 1 to this place, 1 to this place. Okay, then I have remaining only 2 here. If I move 1 here, then 2 is remaining here. Move 2 to this place. Move disk 2 from peg B to peg C, and move disk 1 from peg A to peg C. So finally 2 will come here and 1 from here, it goes here. So this is about the Tower of Hanoi problem.